Hi, so one of my passion is using big data in a lot of domains. So if you happen to follow my columns in my bulletin, you will see that we are showing different use cases where big data is applied in different domains. So for today's talk, I'm going to apply big data analytics tool in the field, in the domain of network security. So first off, we cannot talk about big data without giving a brief background. So big data is described by 4 V's. The first V is volume. So it's just natural to project that with 6 billion people, out of 7 billion people in year 2011 having access to mobile phones, you can see that the volume of data generated by those people alone will grow geometrically. Next is velocity. Not only are the number of people growing, but the number of network connections per person is also growing. It's now estimated at 2.5. Thirdly, variety. So while we are used to syslog, firewall logs, web logs, big data can be harnessed to use other sources of data like social media, Facebook and Twitter. As you can see in the slide, there are 30 billion pieces of content that are generated in Facebook as of year 2011 on a monthly basis. Finally, veracity. They made a survey and it seems like 1 out of 3 managers do not trust the veracity of their own data. So having said that, let us think forward into the future. What can big data do for security? Well, it points to a period of coming crisis. Essentially, all of us in the security arena will be faced with more threats. But there are even fewer professionals that are being trained or created on a yearly basis. So what they're saying is, by the next year, there will be a projected shortfall of around 1.5 million IT security professionals. And in fact, I've come across several articles that said that some IT security professionals are in fact being paid more than the CIOs of other companies. So with this crisis, how does big data help IT professionals? So in a short sentence, big data analytics tool, as we will show in the cases later on, will help us to do more with less. It's what EMC calls the intelligent-driven security. So at the same time, let us describe the 3 types of big data analytics. The first one is what is the simplest to do. You and I can do it within an hour. It's what we call descriptive analytics. It basically answers a simple question. Given terabytes of network security data, can you tell me what has happened? So simple, right? The next level up, or the next level of complexity going up, is what we call predictive analytics. It answers the next question. So now that we know what has happened, can you help me understand what's going to happen based on what we know now and based on what we see from the network data? Finally, the third type of big data analytics is what we call prescriptive analytics. Not only do we know what has happened, what will happen, but prescriptive analytics can also say that if you take this course of action, it will optimize your revenues or it will minimize your losses. So those are the 3 basic types of big data analytics. Now the first benefit of using big data analytics would be faster forensics. I present to you a case where we had one of our web-hosted clients, their website got defaced. And so because all of the data are centralized into one big silo using Elastic's database, well, when it was hacked, we took a cursory look at our traditional monitoring systems. And as you can see here, there was no outlier. There was no abnormal patterns. This is the average response time when we monitor the server performance. This is the CPU load. So typically, those of you in the admin field, you will know that if you are being hit with a brute force attack, you will see CPU going up. So here the CPU will look like normal. Even for memory usage, it was fairly constant. And even in bandwidth, you don't see the telltale sign of a spike going out or coming in. However, because all of the firewall logs, web logs, proxy logs were centralized in one place, we just issue a simple command. Search for all data within the last 7 days where the HTTP verb is post and the destination IP is the IP of the defaced website. And in less than 15 seconds, we see this. So I'm sure all of you understand what this is, but for the benefit of the non-technical people, it means that there were a couple of people with several IP, which is the source IP on your right. And what were they hitting? They were hitting the admin.php logins. Now, we can then present this data in a histogram. So histogram shows clearly what time the attack came in, which was around between 6 and 9, so around 7:30 or 8. And then we could ask the system to give us a top 10 report. Among thousands of IPs that access this particular website using this particular IP URL and using the post, who were the top 10 users or top 10 source IP? So in a matter of few seconds, we already have a list of 4 potential suspects. So having called up the client and then confirmed which of these 4 IPs are your authorized IPs. And they said the last 3 are ours. So it only left the first IP as the suspect. And then because it's centralized, we can go back to the database and say, okay, this IP belongs to the hacker. What else did he do in our entire network coming from the source IP? Right? Now, just as an aside note, my suspicion here was the hack was probably an inside job, or one of the authorized users was compromised with a keylogger or something, where the access pass to their admin login was compromised. So that's my personal opinion. So the first benefit was faster forensics. The second benefit that we can see of using centralized system and big data analytics would be to shorten the breach detection time. So over a span of 4 years, from 2012 to 2015, we have seen that the breach detection time has steadily fallen from a high of 416 to a low of 146. But that 146 is actually 56 days internally. Now, what we would like to share with you is that using big data analytics, we can even shorten that detection time to a matter of hours or minutes. So this is one case where we can apply big data analytics technique. You get the volume of, you get the actual full gigabyte or terabyte of traffic, and compress that or aggregate that, summarize that, and visualize that into what we call a tree map. So each big square represents an aggregate detail. So the big square over on my left side are the total port 80 traffic. You will see a smaller square that represents the total DNS traffic, port 53. Now let me direct your attention to port 80. In the port 80, inside port 80 are smaller squares. These are the details of the larger traffic for Port 80. And one immediately stood out. This item, this square, represents a total number of port traffic to a website that is known to be small, to have small traffic. Therefore, it is an anomaly as far as our network guys were concerned. They were not supposed to have that big a traffic size. So, given this, we're using big data here to analyze or to further filter our area of investigation so that we don't have to investigate everything. So when we did a closer inspection at all the Port 80 traffic into this particular IP, we found that majority of the traffic were to an application plugin inside the web called Drupal Chat. We called up the client and asked them, did you install Drupal Chat? Answer, yes, we did that 4 years ago. Are you using it now? No, we actually have stopped using it. Therefore, why don't you just shut down that application, that plugin? So they did. And what happened? We're showing you the effect on the CPU of that server the moment they shut down that plugin. So next is a case of using descriptive analytics, using visualization on fumbling data. Let me describe what fumbling data means to us. Fumbling data is a way for us to separate the good from the bad. Because the good traffic will typically hit only your authorized IP using authorized ports, for example, port 80. But the bad guys, they don't exactly honor the good, the open or the closed ports. They don't exactly know which of your IP block are actually active. So they will tend to hit everything. Do you follow me so far? They will hit everything. So a clear distinction. So whenever an IP, source IP, hits an IP of yours within your IP block that you know for a fact is dead, is dark, it's not active, you are more likely to suspect that this traffic here is bad traffic. So here is an example of using query to say, like, you know, even though there's no web defacement going on, let us be proactive and see what types of reconnaissance attacks or preparatory breaches have been happening. So here we say to the system, show me every access to WP includes, this is a WordPress system, or to WP admin, where the status is an error between 300 to 600. So this command line can be saved as a script so that you can run it very easily. Or you can have your junior administrators run it every day or every hour. And what you get is a list of attempts. A list of attempts happening across your entire network. So in this case, there are XML RPC attacks. They're using XML RPC to do brute force guessing of your password. Histogram will show the pattern of attack. What time is highest, what time is lowest. And you can even plot this on a geographic map to show, hey boss, you know, these are the attacks coming from all over the world. The larger the circle, the larger the number of attacks that we are seeing. Okay? Again, you know, it's impossible for us to write abuse emails to every attacks. So we just concentrate on the Pareto rule. 80% of the total number of your attacks comes from 20% of the known IPs. So you just have ask your system to give you the top 10 or top 20 attackers. And there you go. Those are your top 20 attackers. And what do your systems, your junior sysads do? Send an abuse email to each and every one. Over the last 3 to 4 years, we estimate we have sent over 10,000 such emails. We're doing our part to help clean up the internet. And over the last 3 to 4 years, we have seen our bandwidth usage steadily fall while we are increasing our clients. We are actually saving our companies from unnecessary expense by being more proactive in security. Case 3, we were engaged by this school, and I was talking to, I think, Dennis Alvaro over there, about this mystery. This school comes to us and consults with us and says, you know, I'm buying 20 Mbps of traffic. I know we're getting that because, as you can see from this graph, we are getting 20 Mbps. But my internal network is very, very slow. So we took a look at the LAN. The input is 20 meg, but the output going to the LAN is only 8 meg. So the mystery here is, where is the difference? Where did the 12 meg of bandwidth go? And 12 Mbps of bandwidth is expensive in the Philippines. So at this point, I would like to stop here and solicit some guesses as to where the 12 meg of bandwidth went. I have 2 mooncakes over there that we can give out as prizes. So any guesses? Where did the 12 meg go? Jerry, 12 meg. 20 meg comes in, only 8 meg go out to the LAN. Come on guys, I'm the only thing between you and lunch.
We'll add up some shirts to Sir Wilson Chua's mooncake.
So 20 meg comes in, 8 meg is only 8 meg is used. So why are you paying 20 meg when you're only able to use 8 meg?
We got a hand raise over here.
Could it be possible that the other traffic are malicious traffic that are just being dropped?
I think he's hit it on the head, on the nail on the head. Correct. So it so happens like, so when we did this, we use packet sizes and cross-reference that with port numbers. If you were to tell or show your boss this table, he doesn't get it. No one gets numbers. But you show him this histogram. So let me explain the histogram. You have pin sizes of packets. The first largest column that you see is under the 0 packet pin. It doesn't mean that the packet size is 0. It just means that it's between 0 and 575 bytes. A normal histogram of a normal network looks like a bell curve, correct? In this scenario, this university had most of its traffic on the lower end of the spectrum. And so that immediately alerted us that something weird is going on. And so we also showcase, where are these packets coming from? Is there a common pattern, Now, if we now graph the traffic by port number on the side, and then the blue color is the packet size, you will see that a lot of them are small bytes, and the majority is onto service port 1. Now, service port 1 is TCP MUX, and TCP MUX, if you Google it, is used by botnets. So the answer here is correct. The firewall is dropping 12 megabytes of traffic because it is correctly filtering it out. So he gets the mooncake and the t-shirt. Now the next question is, now that we know where the missing bandwidth is going, we want to know, what can we do? What can management do? So we look at, if there's malware coming in, what is the malware going out? So we drafted internally the source of traffic going out by the IP addresses. So you will see here, those are all internal IP addresses. And these are the top 20. So we show this to the sysad and say, sir, we think these are the IPs that are infected. And true enough, they said that, oh yeah, we know we run this antivirus. This is a Sophos report. And Sophos has detected 32 infected PCs on the lab. So you can imagine that as soon as they cleared that up, their bandwidth pattern came back to normal. And they were now able to use all the 20 meg for their university. Unlike before that they were paying 20 meg but only getting 8 meg. Now here's an idea that I myself did not know how to use. So it may not be sexy, but you can analyze your terabytes of traffic data by simply using the number of sessions to figure out if there are precursor attacks coming onto your network. So TCP handshake, three-way, right? You have a sync request, and then a sync ACK, and then an ACK. So a valid traffic would have at least 3 sessions. So knowing that, what we did was we asked the system to show us all the IP traffic where the total number of sessions is less than 3, right? So these are all what we got. So there's a lot more. It doesn't fit on the screen. So again, we cannot show this to our C-level executives. They won't understand that. But they would understand this. They would understand that every dot, every circle on that map represents an attack for IPs with less than 4 sessions. And as a bonus, our system was able to classify those sessions into 4 categories. Attacks to a potentially dangerous application, attempted denial of service, attempted information leak, and potentially bad traffic. So it's even color-coded. Any questions so far? Sir Dennis?
Let's say we know the problem. So can we ask the help of the telco? Let's say, can you filter these IP addresses that one attacking our device or routers? Can we ask the help of that telco?
I have a personal answer, but before I share with you my answer, maybe somebody in the crowd that are affiliated or working for Globe or PLDT, can you come up and say what your policy is? If a client of yours asks that malicious traffic be filtered at their end so that you will be paying what you're needing and you will not end up paying for attacks on yourself, right? If they don't block the attacks, in effect, they're making you pay for the attacks on your own network. So anybody from PLDT or Globe? So I can tell you from my personal experience, I have escalated hundreds of times to the telco. Can you please block this port? Can you please block this attack? And they will tell you that, out of our hands, but if you really need the DDoS filtering, we have a sister company that can do that for you at a added fee. Okay, so how much is it? So if you were paying $1 for your bandwidth, the DDoS is about $3 for that same bandwidth. So parang, Thank you, Sir Dennis. So, all the cases we've shown so far were descriptive analytics. You can do this on Excel, right? This one is a bit harder to do, but we will try to simplify it. So case 5 is using predictive analytics. We want to reduce breach detection time. So how many of you have seen Minority Report? Right. So in Minority Report, they go after the criminals who have yet to do their thing. They were just thinking about it. The minority police will come here and, grab you and say, we are preventing you from launching an attack. This is exactly what we aim here to do. So predictive analytics first saw their predictive analytics was first created to help companies predict, let's say in banks or in telcos, which of my subscribers are likely to churn. So using a bunch of data, they will say, oh, okay, you and you and you are likely to churn, so therefore I'll give you a better service or something. So now we ask ourselves, can we use the same predictive analytics method to predict which of this traffic coming in are bad or not bad? Simply lang, bad, are you bad or are you not bad? So here's the general process. First, you have to train the machine to learn the definition of good and the definition of bad. So you provide it with actual traffic data that you label. So you have a port, IP source, destination IP, this is what they did. This is not bad. And then you go along and this is bad, this is bad. So you have a training set. Then you load that training set into a supervised machine learning algorithm. In our case here, we just use naive-based algorithm. Some people like to use artificial neural network. Some people like to use decision trees. Whatever you feel is better, go for it. That machine learning will create a model. So if it were a decision tree, it may say something like, if I see a traffic to port 22, that is an SSH. But since we're blocking SSH, there shouldn't be an access to port 22. This is bad. So it will create rules on its own. It will detect the patterns on its own. That's the beauty of the system. It will detect traffic. Once you have a model, you will then have to validate that using what we call a validation set. This is an unseen data that has not been worked on by the model. So for math and stats major in our crowd, that will solve the problem that we call overfitting. Once we're satisfied that our model performs correctly, we can then do what we call prescriptive analytics by putting this on our bad list, watch list, alerts. You can say something like, if the probability is higher than 95% that this item is bad, block it altogether. So at that point in time, your machine learning is the one that is continually adapting to the types of attacks. And it doesn't need to look into the stateful inspection or whatnot. It just looks at patterns. So here's the actual way. This is a screen grab of RapidMiner. This is one of my favorite tools. So here, you just grab the retrieve module to say, load your terabyte of traffic data, and then pass it to an X validation module, and inside there is the naive-based algorithm. You connect your out to the training set, and then it will create a model. The out is the model, and then you write the model to save it. So you don't have to keep on creating a model every time. So once we did that, how do we know how accurate the model is? It has a confusion matrix. Look at the accuracy. The accuracy is very high, 99.78%. So there's this. There are other terms like recall, class precision, or whatever. But for now, just be aware that the accuracy is 99.78. Next step is to apply the model to the validation set. So this is what we do. We read the model and we read the validation set at the same time. And then we apply the model and we measure the performance. This is the performance that we get. Do you notice anything? What happened to accuracy? Accuracy from a high of 99.78 dropped to 66.13%, not acceptable. So that got me to do a further investigation. This is what your data set will look like. You will have a column called class type. This is what we call the label. So my people labeled this traffic as not bad. But the model said, no, these are bad. So what we did was we took a look at all this traffic in detail and found that these supposedly not bad were actually bad. So this is a case where the model correctly predicted the status. So all of this traffic to this 163.73 were for Drupal chat room access. So correct. The model correctly predicted and was even better than human scorers. So, to end my presentation, let me share with you some of the tools that we use. This is the source of several ideas on what to do with your network data. I recommend you to buy this book and keep it as part of your library. Network Security Through Data Analysis. He's the guy that showed me the value of just looking at packet sizes or just looking at number of sessions. Remember, we're not even looking at signature levels, just sessions, just packet sizes. Then, obviously, if you want to store your data in one single location and you don't have the budget for EMC or Hitachi or Huawei large storage servers or IBM, you can go for Hadoop or you can go for Elastic. That's where you store the data. And then you can either use Graylog or Splunk. I use Graylog. It's free. Splunk is about what? $10,000 a year. I doubt if a lot of SMEs in the Philippines can afford Splunk. For data visualization, there's Click and Tableau. I'm certified in Tableau 9.1. Any questions so far? Then, there's this whole other side of big data that has to deal with graph databases. So it's another type of activity where we can use Neo4j or Gefai. So if you're familiar with Panama Papers, they use Neo4j there. Finally, for creating predictive analytics or the heavy-duty stuff, I would recommend either 9 or RapidMiner. Now, 9 is completely free. RapidMiner is also free, but they recently came up with the newer version that would restrict you. The free users are restricted to 10,000 records only. So if you haven't started learning predictive analytics, I would say you start with 9. Para hindi sayang. Kasi, but if you use RapidMiner, you will find 10,000 records as not being enough. Because we typically work with what? 1 million records, 3 million records. And so RapidMiner will not suit us. So again, most of these items here are free. And finally, if you want to take a screenshot, these are some of the links that we have. We invite you to join PH Internet Facebook group and also our Big Data Analytics group at the last link.